Okay, I think we're live and ready to go. Trying a new layout, so if anything's too small, let me know. For example, these files. Okay. So on the right, there's actually some chat, so you can actually see if that's working, because I never know if it's working. It says it disconnects, and then I don't know if it reconnects. But otherwise, I'm going to give an overview of what I'm trying to do and why. Actually, so kind of the ultimate goal, although there's kind of a number of things that you can do with this. Hello. You're not showing up because you're under my my face, but the chat's there. Welcome. So Hugo, static site generator in Go, very fast, very powerful, flexible, simple. I've been using it for static sites for a while, and usually in a CI loop. So I have a static site, and then using Circle CI, when you deploy to master, it'll build the site and push to GH pages, which deploys the site. That's where I put all my static sites, which works okay. And then, but to make any changes, I have to go through the usual. Hey there, Chrono. I doubt that's your real name. Is that your real name? So instead of checking out the site and going through the normal Git workflow, I actually want to ultimately build kind of a little local web app, or even Heroku hosted web app that gives me sort of more like a hosted medium-like experience with my static sites. And so so I kind of want to continue to use Hugo, so I'll build that around Hugo, but to kind of make this a little bit more efficient and have it kind of directly read from GitHub and publish to GitHub, Hugo, the author of Hugo, actually wrote a number of other really great libraries, one of which is this library, which is more of an interface, and it has a couple of implementations. So Go lets you, the OS package and such kind of lets you work with the file system. This is an interface for file systems, and that's mainly its main purpose, right? You can use it comes with a basic implementation for, that wraps the built-in OS stuff, but then you can also create in-memory file systems or anything else that implements this interface. So it's really great when you can program to an interface. And file system is such a common one. It's really great for testing and stuff like that. This really should be in the standard library. But so Hugo actually programs to this. So if we create a custom implementation that works with the GitHub API directly, then we can basically run Hugo from anywhere and have it just pull the files from a GitHub repo branch and then write to a GitHub repo branch. And that's the theory, and it should all work. So the first thing that I need to do is implement this interface and have it backed by the GitHub API. So instead of shelling out and doing anything on the file system, you can actually work with Git via their API. You can use kind of more of a low-level, let's see, would it be? I mean, it's Go, so it can be work for anything, especially since it's not a real file system. It's purely, so it's kind of confusing. That's why I was quoting file system. But you can create actual file systems in a number of ways using Fuse, doing network file systems. Like I've done some projects with 9p. It's kind of a nice alternative to NFS. And those are really great ways to be able to program new file systems. And you can do all of that in Go. The idea here is that it's more of a virtual file system that existing programs or new programs can program to as if it were working with the file system, but it'll actually be working with the GitHub API. So because of that, it'll work on Windows, Unix, Mac. So that's a pretty good question. And then, so we have this low-level stuff. There's actually a high-level API in here that lets you kind of work with file contents in a little bit more straightforward way. We might use this for some operations, but I think for a lot of operations we're going to have to use the low-level API, which is a little bit more steps because you have to, as far as I understand it, you know, given a branch name, you look up the reference, and then from the reference you get, let's see, what would this be? Oh, I might have to look up the first commit, and then from the commit you get a tree. Yep. And then from the tree, you can then list all the files in that file. So there's kind of a lot of steps. There might be a quicker way to do this, but because you look up trees with these kind of commit-ish stuff. Oh, Andy, hey. Yeah. Welcome. So that's I think what we'll do. I haven't really worked with this API a whole lot, so kind of bear with me. Then there's also, this is the library that we'll be using. It's sort of the more or less canonical Go library for working with the GitHub API. We might want to start out just kind of testing this with my key just to make sure that works. And then maybe even doing some kind of like debug stuff. Actually, it'd be really cool if we could find something that uses afero. I'm assuming it's pronounced afero, by the way. If you know that it's pronounced any other way, let me know. If there's a library, like what would be really cool is if there is some kind of like shell or something that programs to this, because that would be a great way to kind of debug it interactively. Let's see, there's not a lot of, doesn't say what projects are using this. I feel like that's something that SourceGraph might know. Go library. Oops. Trying to see if something like golibs might list something here. Yeah, it might be even I don't see any. Compliant interface to S3. So these are all other implementations that you could use. This is nice. I might want to keep a note of that. Overlay file system. Well, at least anything that uses it as opposed to implements a new backend is not mentioning it in their metadata, I guess. If anybody knows a way to look up libraries that use certain packages, that would be cool. So I guess I'll just have to kind of do some debug stuff myself. Let's just start building a main. Oh, Adam is incredibly unresponsive today. That's usually how I start everything. See if I can get this. Okay, so let's start using this GitHub library. Make sure I have it. And the first thing, let's see if they have a good client. What does this do by default? I probably need to file. Yeah, my access token is in my environment, so I should be able to use that here without hard coding or putting it on the screen. I'm gonna do this and just see what this returns. We got this. We should have auto. I'm not sure why it's not auto. Fixing those imports. Yeah, I'm not quite sure why it works sometimes. Context and OAuth. It should also like try and build this too. What's going on? Oops. Let's run it. Yeah, I kind of want to. I mean, I like. Oh boy. I like Atom, but some of the plugins are not ideal. All right, so this works, and it's actually telling me what. Yeah, I have a lot of repositories, so just want to make sure this is doing the right thing. These look like my repositories. Since I have some other company accounts and stuff, I wanted to make sure my GitHub access token was my personal one. In theory, I could also do something about Git user. I don't know if there's a pagination, activity service, authorization, I think is what I want. This is what Git authorizations and Git user. Oh, this is, I think this is not actually what I want, an authorization. Yeah, it's not, that's not what I meant. I wish there was a good list of all the different API endpoints. They're not always named exactly the same as the API docs. Although we should take a look. The one that I'm always using to test is the current user. That's kind of strange. Why is this? Get a single user. Why is this in this section? Did they change this? That seemed kind of weird. Get single user, get authenticated user. wonder if this API is out of sync with the docs a little bit, because I don't see any of these endpoints. Am I looking at the wrong thing here? It's version 3. What's it called? I should be doing authenticated. Authenticated. Start subscription. Seems like everything's in the context of the currently authenticated user, so you'd think there would be a something here like get users, user service. I mean, I guess I can just do this, right? Maybe that's kind of what it expects you to do. Do you have access to like the current user or something in here? I don't see anything like that, but we can just do this and make sure this works. Membership, pull request, and all of these have get user. The other thing is it's not telling me what the signature is. Usually it's telling me that down there. I'm assuming it's going to be like user response error. Okay, well, let's try and get some list files from a branch of a repository. So something like, actually, I wonder if as a quick, if there's any kind of shortcuts in here that we can use to get faster seek commits, something like this, that we can get to a tree. So we have refs, trees. This is just metadata though, so it's kind of parent. And we can kind of, all this stuff is actually kind of frustrating because it's usually not anything that's actually useful for the user of this library. It's all for kind of libraries and stuff. Okay, let's do get repository. What's a repository I have? Could use this one. Yeah, let's do that. It's nice and small. Owner, repo. This will be a repo. Ton of data. I forget, is there like a good pretty print other than just doing like YAML or something? I just want a little bit of, use this one before. Pretty formatter. Interesting. Okay. It's pretty readable. It's nice that they do references and stuff. And types. It's been a while since I've used this. I wonder if it's improved because it's pretty nice. Master branch, default branch. Let's see. I mean, I guess I'm gonna have to just go into the trees. API. Where did I look that up? Here. Get data. Let me double check though. Repositories. Commits. Branches. This might give us a quicker commit tree. That's nice, because if you just get a tree or a reference, you then have to look up the commit, at least what it looked like from the doc. So this will let us put in a branch name and get the SHA for the tree. So let's try that. Repos, branches. Commit repositories. Get branch. Oh, now it's telling me the signature at the bottom. Owner, repo, branch. Master. These are all prototypes. I'm not actually just handling errors. Okay, so from this we can get a tree. I guess we have to get it from the first commit, or the latest commit, which should be the first commit, right? Tree. I don't know if trees are mentioned anywhere else. Committer, nope. Branch, commit, commit, tree. Okay, and we get our SHA, which is a, let me see if I have these wrappers so that you can actually get a non-pointer. Cool. So this is our tree hash. Now we need to look up that tree. Get data, trees. client get tree context owner repository. Probably need a SHA tree hash and recursive. So fetch more. I'm guessing this is if there's directories, it'll include them. It's not particularly clear, but I guess that's enough. Recursive true. Tree response error. No, don't care about that. So now we can look at this tree. Okay, we've got a list of files. That's pretty good. What is this content? Nil. Oh, it's nice that there's a URL. I wonder if there's any helper stuff like tree entry 0 get content. Like I wonder if that uses the URL to look up the content. Guess I could try. First file is a get ignore, and I know there's stuff in it, right? Yeah, so maybe I'm not sure what the point of this is. Is this the right commit? There's only one commit, so that's interesting. This is not okay. This is the tree ID, and this is the bool entry. Maybe I'm not remembering exactly. There's a SHA for everything, so it's kind of hard to see. This isn't actually telling us what the current commit is. You'd think it might be this, but this is different. I mean, let's try and get the blob for this now, which is so weird because it's giving us the URL, but then not actually looking it up. So we would kind of manually go look it up now. Blobs. Get a blob. Client get blob. Owner repo. SHA. So this is that. Blob. And then get encoding. See, it's not going to do the decoding for us. Or it should. I thought it did, but maybe it doesn't. Okay. Well, there is content there. I thought for sure there was something that would decode it, but maybe that's a different API. Let's see. Create a blob. Always base64 encoded. So I guess we'll just have to decode it. It is a string. So there's nothing that gives us a string afterwards. It's kind of obnoxious, but blob get content. So we're kind of just feeling out the API and some of the obvious things that we're going to use in the implementation of the file system. Getting comfortable with using the API, so this is all just kind of like prototyping and stuff. We want this as a string. What's that? Two options. Do I ever get UTF-8? It doesn't say what I could. Oh, it says these are the supported ones. I think this is for input. I think, yeah, when you get stuff out, it will always be base64. So that's nice, I guess. So I don't have to do any checks. Oh boy, I don't know. It's not automatically. It's like auto-completing, but not actually running the go import hook. Sometimes it does, so I'm not sure. Okay, so now we have, and ultimately we probably want bytes anyway, so this is pretty good. Let's look at what else we would want to implement or need to implement in here. So changing file modes is interesting because I don't know if Git actually records that. I mean, we could always kind of no-op that. But how does Git actually store? I don't think it does because it's just going to be whatever. I mean, file modes, like user, it's going to be whoever checked it out, but isn't there like a file mode if you change a file mode on something, it sticks. So that's kind of interesting, right? Maybe that's part of this file. Oh, yeah, file metadata. So we do have that. We got it from the tree. Okay, so we get that from the tree. This is actually setting it though. How would we, I guess, oh boy. Get a tree, create a tree. What are these that we're getting back? Shaws for what? It's just like a reference or what? So these are going to be just those kind of objects. This is kind of strange. Does anybody know first of all, what type of data is this tree returning? Like, where could I look up this SHA? And how can I write this data? Maybe it's just not exposed, which would be a bummer. This might be where I need to use this other API. Update a file. I can update the path. I can update the commit message. I need a commit message. Update the contents. Optional parameters. Author. It's interesting you can't set any of the metadata. Archive link. So maybe we just can't set, I mean, I feel like that's something that we would need. Directory representing a tree. By the way, hey Elijahs, good to see you around. Representing a tree is always a blob. Directory, so are blobs also metadata? Because So if we have a tree and this, in theory, yeah, so this is in theory representing a blob, right? But a blob doesn't actually give us any of this information. So that's kind of weird, right? Like, where else can you get this file metadata? Because I would imagine that's where you would be able to set it as well. You can only get a tree. Maybe it's like metadata and a commit. I don't know. Parents, not. Can help show what it points to. So I'll, I guess, go back and get that show. It's from the, let's print out the tree. And then, whoops, what am I missing? Nope, that's fine, really. Oh, you know what? Let me know if this is too small. All right, hit by imports again. Come on. I only really run into this when I'm doing this kind of code, right? When it's like changing, and I mean, it helps if when I save it would compile and tell me stuff. So you're saying I could grab one of these SHAs. This is assuming I have it checked out, which I do. So I'll try doing this in the repo, and this should be the same SHA as it is locally. Cannot handle cat file as a built-in. This is like some special command cat file. Oh, cannot handle cat file as a built-in. Well, I don't know what that means. Pretty print objects content. No, this is not cat. That's cat. It's not Kit Kat. Kit Kat. Yeah. Well, I mean, I've never used this. Commit head. Do I need some more data? No. Strange. Blob tree. Those are the only objects I know of. Where is the metadata? I guess it's just metadata of blob, and GitHub's not exposing that, right? So if that's the case, that's fairly obnoxious. Let me see if there's any other resources that might give us access. It's not the meta I want. Migration. No, this is not what I want. Import a source repository. Apps get data is the only thing here. Change content. I mean, a commit is able to change metadata. So, right? So in theory, I should be able to create a commit. But the commit is just going to point to a blob. So this might be something that we can't write. Let me think. So if we were to write a bunch of stuff in there, create a tree parameter. See, we can, when we create data, we can provide metadata. We just can't modify it. So maybe that's actually good enough. We'll see. It's going to be weird because I don't think this is going to kind of work like that. I guess the idea is, let's see, create. Yeah, this might be an interesting blocker because we can do a lot of this. What are we saying here? Java, get internals, get objects. Yeah, I mean, I'm assuming that it's actually metadata on a blob. And so the real problem is Git's API is not exposing it to us other than in a read-only fashion from the tree or right up front. Like we can't, I guess we can just Google this, right? GitHub API change file mode. Change file mode on GitHub. This is, but we want to do it through the API. Commit file to GitHub API. This might have some helpful stuff. This might have something helpful. It's gotta be GitHub structures, yada yada yada. Post a new file. Yeah, we would post it to the blobs. Oh, if we edit a blob, is there? We can only create a blob, right? Because that's but there's still no like metadata here, and that's really weird. I guess I should take a look at this to see where the metadata actually is. Let's like look for file mode. Okay, tree object, single tree object contains one or more tree entries. Okay, so entries is like a first class. Doesn't seem like first class. It's like an embedded type of the tree object. Create your own tree. Tennis, plumbing, use command. Other options. Trees created from the index stage. Oh. Okay, well that's what it's doing when you use the command line. Okay. See, this is exactly what you told me to run. I'm not sure why it was acting weird about it. What was that error? Cannot handle cat file as a built-in. Why not? Do I have like a weird version of Git? It's probably old, but I imagine it's not like super old. Latest 2.15. I mean, I could probably update it. I mean, I might as well, right? It's not gonna sort of indirectly help, if anything. Create a new tree with second version. What? So are trees immutable? Is that the idea? If I want to change info mode, I create trees, verify a tree object using the same. Create a new tree with the second version of test. Okay, so that's how I have to think of it, is trees are, I was kind of thinking they were like stateful things that you would change, but that makes sense. Everything's kind of, I mean, tell me if I'm wrong, but every tree object, any change to a tree object creates a new tree object. Let's try that file. Oh, still not having it. I guess we can test this theory though, right? We can let's see. Cat file. Maybe I should start from the beginning. That's odd. This is just saying that that object's not there. I mean, these files were there. It's interesting because those files were created by GitHub, and they might have done them in a weird way. So I guess let's add main initial. It's not really important, right? So now there should be an object for it, and that's interesting. You can cat file trees, so let's try that. I kind of want to see the reference for this tree. It specifies the tree object is pointed to by the last commit on your master branch. Right. So, so there are many trees. I'm just trying to like verify this. Is there a way we can see, where we can see the list of trees are used also as directories? That makes sense. Okay, this makes a lot more sense. I'm just going to assume that they are kind of these immutable objects. So if you were to change metadata on a file, you would create a new tree. Good to know. Yeah, for all objects, not just the blobs, because I knew about that with blobs, but okay, well, that's good. That's kind of consistent and makes sense. So if I wanted to change some file data, I would actually want to create a new tree and kind of manually link it up with a commit. Okay. Commit messages are going to be weird because they're obviously going to be no place for them. It'll have to be like created by FS or something. I guess it can be configurable. Okay, so that solves changing file modes and times. I don't think we have that right in the GitHub data. It's just like, I mean, we have the commit times. I guess in theory we could do something with change times doesn't make sense. So this can be a no op. That's fine. Create, rename, stat, and we'll have to assemble file info. File info. Give me that. Name, size, mode, time. Yeah, it's all based on, that's all local system stuff. So I guess it can be based on the last commit or something. I don't know. That doesn't seem like that important. We can kind of fudge that pretty easily. Okay. I think we have an idea of how we would implement all this 50 minutes into this. So let's see, what would be the easiest thing? I would love to have like something that tests these. Is there like a tool that we could use in here for like testing these interfaces? I know there's these like helper things. Maybe you could just use one of these. Read all, reader, which gives us a bunch of file info. I guess. Yeah. If we're gonna, let's just kind of get into programming this thing. So we'll need a reference to the GitHub client, which is GitHub client. It's very likely we'll want to lock on operations because of the network stuff. Anything you want things done in order, so I guess we'll set up a little mutex here. Mutex. I'm going to add it for us. And what else? I guess that's good. And we can just grab the I don't know what that means. I think this is all I have to implement. Let's actually look at the interface. If it has a file. Oh boy. So it's implementing a file, which then has these. Okay, so it's a little bit more. Work than just kind of doing like a stateless API like some other ones. We can do kind of no ops for all of these and then start return nil, return nil. I guess this would be what, return GitHub. I'm not sure what it means, if this is like an internal thing or what. Oh, file info. Can I create that struct? It's just a struct, right? Interface. There's probably some useful stuff in the like the in-memory implementation. Because that's kind of what this is we would be putting it in memory. And maybe that's the first version, we actually just kind of keep everything in memory. Because we might need to for some of the order of the operations. File, yeah, so then they implement a file info based on the file data structure. New file, handle file, and then create file, set mode. I'm guessing we'd have to like write into it. Like it doesn't have an easy way to just like set the content. I'm thinking of just using these internal in-memory data structures that already implement files. Let's see, file data. So if I have to create file data, but the only way I can create a file data is by name. I guess I could just manually set this up and provide the data. Yeah, why don't we do something like that? File data. What are we trying to do? We're trying to create a file info, which looks like, how does it, oh, it sets it up with a file info. So I'd create a new file data, create a file from that, and then get the info. We can try all that. I mean, yeah, this is interface. I can actually return nil for that for now. I'm going to finish doing these no ops. Oh boy, return file. I guess that'll be nil too. There's a lot more of these than I thought. Okay, we're done. So what was I doing? So it's gonna do something to create file data. So let's make like a create a file with name, data. I'm always, yeah, data, and I don't know why it's returning, this create file is returning a file data. I guess file handle. Okay, well I'll just wrap it, I guess. So create file is going to get back a file struct from afero mem. So it'd be like mem file. Oops. This is a struct, so it's going to be a pointer. Don't have our own file type. Just using all of that. This is not what we want. We want file data, which we can create here. File data, name, file data had a data, so we can just set that. Data is data. Maybe do this. This is mem file data. We should do that import. SPF. There we go. And then, okay, so if we wanted to create an empty file, get some file data, as we try this, right? Let's print create file name foobar txt hello world. Let's see if that actually works. Oh, I haven't run it in a while. Whoa. Those are all internal. So I'm not going to be able to set them like that. Well, and I guess I just copy this, right? I could create the file. Do they have a helper where I can just set the data, because I don't want to write into it, but I guess I have to write into it. That's not that big of a deal. Okay, so at least they do have some public. What? Create. Is that a typo? Maybe I need to update this. I mean, I meant this, but probably does the same thing. I'll just get it and assume. Oh, it's my own typo because I didn't put mem. Okay, create file name. It's gonna be file data. File data, we can we write into a file data, or do we have to create a file handler? I think we have to create a file handler. Kind of a weird data structure they're setting up, but I can see where it came from. Create file handle. See, that should be there, but it is not. Oh, new file handle. File data. And then we can write into it data. We'll just assume that that works. I imagine we want to like seek back to 0. Right? I don't know what. Once is 0, 1, or 2. Maybe I should actually look up the, how does that normally work? Is there an OS seek? Seek relative to the, oh, this is where it's relative to, so origin, so we want 0. Seek 0, 0. And then we'll return this file. Oops. How's this? Surprised it's, keep saying that. Surprised it's not actually running that, so it's kind of useless. Okay, what are we confused about here? Create file 31. Oh, we got all these file references. I guess we can make these all. It's interesting, they're not pointers. Oh, they're interfaces. Of course. Right. File. Okay. Time. Let's get time in here. I don't know what MT is. Who did that? I don't even see that. Is that a variable? 114. Oh, that's odd. Okay, sure. So we have a file. That's pretty good. So I can create files, virtual files. So for example, we could do this. Maybe I'll even take this out. Create file name. Yep. Directories. Oh boy, how are directories modeled in this? I know Git doesn't have them, which might be interesting. Is directory. Create directory is, I see. File data with directory is true. Let's see. And we'll just, we're not going to do anything with it, but we'll just create it. Create directory name. It has a set mode. Perm. This would just do all the same. I don't know if we're gonna have to create a loop. It depends on how we structure stuff, so I'll leave this out for now. Opens a file, says this assumes one exists. I will leave that one as well. Open file, opens file. It's kind of the same thing. This probably wraps this one. Remove all, rename, stat. And this is the one where I can, if we had a file, we can just do stat. Okay, so we're getting closer to pretty easily implementing these. Interfaces. Let's see. I wonder if we want to do. We want to do this lazily, or see. It's tree. Okay, so maybe we have a top level tree object. Okay, so I'm going to do new GitHub FS, and we're going to take the user repo branch and get back a afero file system or an error. I guess we also want to pass in a client, right? GitHub client. Yes. Client is set. This is a good place to, probably we just want to keep all that in there because I don't think the client makes it very easy to keep all that around. So I'll just set all of those. What else? And then we're going to do what we did down here, which is get the, we're trying to get the tree. So I don't care about the response. We'll get an error. If error, return nil error. Probably gonna do that here as well. It's a branch. And all these places we can do user repo branch. I guess we want to keep the tree. We have a mutex, so this would represent whatever the top level tree. This might change, but we'll just put it in there for now. GitHub tree. FS tree equals tree. I guess in theory we can do that. FS nil. And then see, all the directory stuff is it's one of the weird things about the POSIX stuff is how they do directories. Kind of are represented as files, which is weird, but so get rid of all of this. Keep that around. And GitHub FS client program go GitHub FS master. We'll just, I guess we should start paying attention to what the error is in a very serious manner. So the way directories work, because that seems like a good place to start. Oh boy. read directory file system. So we open it and then implement readdir. Now, if we do directories using the directory. Where is this? Okay, this is a normal interface. That's interesting. Okay, so this is like an internal interface for memory-based things. That's actually really helpful because this actually maps to a tree. So maybe instead of using their implementation, that's where we can start making our own implementation. So we can grab all of this. Maybe we'll do GitHub directory, something like that. And these are mem file datas. Okay. So we would create this from a tree. I don't think this is recursive. We're gonna have a tree. Maybe we can just do GitHub tree. Okay, this then has to be mounted. Add to member. This adds files to it. Initialize. Interesting. So we create a file, then initialize dir. I guess we're gonna have to figure out what a dir map is. How is that used? So this is their implementation. Maybe we do want to use their dir map, I think. Maybe we can do like an embedded type. And then, yeah, let's do that. Mem dir map. So we probably don't have to implement a lot of these, but I'll just set it up. Oh boy. Okay, we got the kind of nested hierarchy parent problem, trying to figure out where to start. So we start by going top down from the calls that we're going to make. So we can do a readdir, down here. Reader is going to give us info. This is afero reader fs. Directory name. I guess. I don't remember how relative directories, like if it actually implements. We could just say root. That's probably the safest thing. Info. Okay, so we're going to need to implement open. So open, which gives us a file. We can do that. Create file. Although I think we mostly just want to do file data and then initialize it as a directory. What is our file data? Create a new file. I forget actually, is that file data, create directory, file data. Okay, so we want create directory. Oh boy. And maybe we don't need a custom type. We just load the directory map that we have set up here. We'll kind of try that for now. So open is going to create a file, new, create directory. Even though this isn't how open will work, we're just trying to get this like initial thing to work. File data. And then we have a directory. Change file name. Okay. So what we can do is start using the API here and then populating that memdir with files. Let's see. File data. Do we need to do that init? I think this is already done for us. I don't know why this wasn't used. Do we have access to? Don't actually have access to the directories. There's no way to. Oh man, we might have to duplicate all this because we can't. I don't see a way to get access to the directory map. Like we can make a directory map and then hold a reference to it, but how would we set it? they don't seem to. Oh. I guess this is how we would do it. Add to member. Yeah, okay. Okay. So given a file data, okay. I'll just kind of put this here, and then I think what we want is new file handle. And let's see, file tree. Carry in the tree hash. I guess given the thing, we'd do something special, like if name is root, then we work with the top level tree. Tree, what do we got here? Entries. Is it indexes second, or I forget. I think it's first, right? So the entry. Ooh. So this takes a file data. So for each of, how do we know if it's a type? Is that what it's going to tell us if it's a directory or something else? Tree. Type, blob, or tree, okay. Type, I guess we want get type. Case for blob, a case for tree, and a default, which I don't know what it would do. Continue maybe. In the case of blob, we would path. That's interesting. We have the size. I guess we'd fetch the data here too, even. And like cache it, because there's no way we can. The mem file implementation assumes that you have the content, and then that's how it drives size and stuff. So for now, I guess we just populate it with like empty files. So what we want is mem create file called, name the path. We can set, ultimately if kind of wrapping this mem file stuff doesn't work, we'll do our own, but this is kind of a, hopefully should get things moving faster. Set mode. Okay, so we have a string representation of the mode. Does anybody know a good way to convert that to a uint32 that would accurately represent the mode? just string conversion. Guess we can just hard code it for now, right? Because they don't actually get into any specific file ones other than the basic types. So yeah. And is that, I mean, but from a string, right? We have a string, so how would we, I guess just convert it to an integer and then do this. But for now, since it seems like they don't do anything, they get more specific than the generic type like blob or tree, we can just kind of hard code it. So that is mem set mode. Which is, what did they say? 644. I need this. We can try that. And then, let's see, file, and then we want to add this. That's the directory, is our file. Okay. Ignore tree for now. And then, so we're going to get a directory listing is all we're going for, and we don't have subdirectories. And it's just the top level one, which we would have fetched. So this could work. Let's try it. Oops. Oh, because we have a name branch. Call it P. Context, we have no context. I guess we should pass a context in here as well. Does the client have access to context? I guess not. I guess we can create a new context. I mean, we should probably pass one in, but just for now. 59. Yeah, this is better. I don't know if that's right, but we've got our listing. That's pretty cool. In OS file representation. That's progress. Okay. Let's see, where would we want to go from here? I'm going to create it. Local directory. I mean, besides the whole interface, I'm trying to think of what specifically we can do next. We started this, so maybe we want to do tree. Yeah, let's try that. We'll do implement tree. What else could we try? I guess we could try reading the files. Okay, we don't have file length, file size, data, because we're not actually getting the contents. I'm trying to decide how we want to do that. Like, initially I'm like, oh, get it lazily, but I don't think we could do it lazily with using this mem directory stuff. So I guess we just have to like walk the file system on GitHub, walk the trees. We fetched it all recursively, so we actually have a list of all the files in the repository in theory. Are you guys saying anything? I feel like, I don't know why, I don't know what that one was. This feels more correct. Yeah, so I guess to test this we have to create some directories with files in them. We can do it in this repository. Test maybe another one, test foo, touch test foo, file. And then also file 1, file 2. What is up with this file 1? This is file 1. This is file 2. And we got this. We'll commit. Push this stuff up. Yeah. Get rid of this for now. Let's see. And we should actually be able to run our program and have it list. Because the directories wouldn't show up, just the files. The main. Oh, that's not what I expected. Oh, those are the files. Oh. The entries is one big list. Okay. So we actually want to match. Okay. Well, this is kind of weird because I was expecting like a, like the test directory to be a tree and then have its own entries. I didn't really expect there to be like one big list because that's the only way this is getting made, right? So maybe we need to look at this list that we're getting and see the structure of it. Tree. Okay. Git ignore license main test tree. Okay, so it looks like any other entry. It's not actually an embedded set of entries. Okay. So we want to do like a path match. Is that what we want to do? For each file, we want to test maybe dir, path dir. Path. So we'll do a normal dir, which is normal. It's a strings trim prefix name. So we get it without root, and then we're just going to go through all the entries to see if e get path if path dir equals normal dir. I guess we could let's see, create directory. I was just thinking about the name. I guess it doesn't matter. Or rather, if it's not that, then we can just continue. So now we should only get the top level stuff. Oop. Okay. Maybe I close Atom and then come back to this project because Atom is acting really weird. Yes. So yeah, I could change it to be not recursive, but that would mean having to go and look it up for every directory. I just figure for now, while kind of prototyping, it's easier to just deal with a fully recursive, like just get the entire repository's tree data. That's what you were wondering. I'm not sure. Just kind of assuming. Oh boy, failed to activate React package. All right, well, cool, I guess. Okay, everything's working again. I don't know what happened last time. I should have just done that earlier. Whoops. Okay, so that's not what I was expecting. Let's stop doing this and I wonder what if, because this should be empty. And this should be everything but the base name. I wonder though if there's no slash. I guess I should see what this is doing. In the case where they're not equal, I just print all of them, I guess. Isn't that interesting? Okay, so it's like apparently it will say current directory. So maybe I should change this. If normal dir is nothing, normal dir equals dot. Might not be the best way to go, but as we keep going, it'll tell us whether that makes sense or not. But this should work now, right? Only the top level files. We also want directories to show up here. So what we would do, so we're actually creating, we're creating a new for memory directory file tree every time, right? Because we're doing dir create file and then adding stuff to it and returning that. That's, I think, fine for now. So here we would say, I think we'd just do this, mem create dir get path, and I think our mode, I guess I'll stick to, is this like the right format? This is kind of this is octal, right? So I need, if I'm gonna just use this, I need to actually have an octal representation in them, right? Golang, file mode, octal. I mean, because if it starts with 0, that's not an integer. That's why it's converting, right? I just thought there was a different way to represent those, like a more explicit way. So, like if I wanted to do this, this looks like an integer. That would look like a, is that right? Golang octal. Do not allow, this is interesting. Long term, interesting. Enter a list of numbers. Guess what went wrong? Some of these are octal, some of them are integer, right? Yeah, it should be like this, but so if I want that one that starts with a 1, I should probably put a 0 before it, and that would do the right thing. Is that correct? 0, like that? I don't know. And then in this case, and again, I'm assuming that the get data, at least from GitHub, is not anything other than these, because it said it was like, if it's a file, it's this. If it's a directory, it's this. Never anything more specific than that. And we will not worry about this. I guess if it's an executable, it's different. D100. Yeah, that's what I thought. I'm like, I don't know. But I'd still want to do, I guess I'd convert to an integer first, right? Or, excuse me. I'm just going to do this. That should work, right? Add to member, that directory, and this is top level still, so D. Yeah. Okay, so this should give us all, file not defined D. This should give us all top levels, including the directories, like test, which is a dir map. When I generalize this, I'll probably end up using parse int just to ensure if they ever give anything different, then it will work. And then I don't have to do anything special for executables. But for now, I'm going to keep going like this. So we've got this. I'm guessing yeah, octal. So I'll 3 y3 starting with index 3. Is that assuming like oh, because GitHub's providing the first those 100, but for file directories it actually you want those first 3, right? So I don't know, it's weird. I mean, it does. I don't think it harms anything if you actually do 100644, right? I would imagine it doesn't, but tree. Let's see. Open redirectory. Now what are we doing? We've got a tree. And so now I want to be able to say, look, let's look at a subpath, so something like test. And then I want to see foo file 1, file 2, which I think this will work already, right? The names probably don't want them to include their prefix though, right? So let's do a normal name where we trim the prefix from ePath, and we're getting rid of the directory part of it, which is gonna, that won't put, if it is period, then we don't need to remove anything anyway, so this is fine. Excuse me. Oh, now it's doing a, I don't think we want that either. Trim get paths. Okay. It would be actually, you know what? I was just thinking, if we, I have a 9p implementation, and I think it would be easy, somewhat easy to wrap the afero FS with a 9p server, because you can, at least in Linux, mount a 9p file system like NFS or anything which would allow us to, at some point, test this with on the command line, just like going through directories, which would be cool. Sort of like a fuse or something, but using a, sort of less moving parts than fuse. Alternatively, there is also a 9p client that is kind of shell-like that we could use to debug this. So that's something else we could do later on. About 2 hours into this, and actually I'm pretty happy that it's kind of coming together. I mean, we have very little of the interface implemented, but you know, we have something that's kind of working, listing directories at least. So, and actually we can list any directory now, right? We can actually look into foo here. Foo file. So we can read directories. We can't read files yet. So maybe that's our next thing. So I guess we did this. Read files. And then we can start getting into writing files. And that's where it's going to get complicated because we have to start hitting the API again and building these structures. Yeah, I do have that extra 0. You mean at the beginning? You said at the end. But yeah, at the beginning. So that it registers as an octal value. What else? Yeah. We could take a look at that. In fact, I don't know if we'll find anything interesting, especially because most of the hard work that we have to deal with has to do with the complexities of the GitHub API. They're implementing their own file and stuff, which we'll probably have to do at some point anyway to properly lazily load stuff. Although, does tree provide file size? It does. Yeah, so if we implement our own, we can actually properly have file info return size without having the content, having look up the blob. So we'll see. I don't think this will be, because again, this is mostly specific to S3's APIs more so than the afero part, which is what we're implementing. But this is cool. So if we implement this, another thing, you can point this to not just a repository, you can point it to a repository's wiki. That's kind of cool. And then, of course, if you were to write the wrapper for 9p, then you could mount a GitHub wiki and edit files locally, and it would commit them to the wiki. That's kind of cool. Weird stuff. I'm not doing it for that, but you know, having those options open, that's the whole point of doing this kind of like building block primitive using interfaces. Some interesting stuff. So probably gonna wrap up this one. Since there are some of you, appreciate you guys kind of hanging out and following along and helping. I'm gonna kind of come up with some stuff, next steps, and maybe continue this tomorrow. But trying to come up with what I want to do next, and also if anybody else wants to like continue some of this stuff, because it'll be on GitHub. maybe someone wants to attempt reading files, not necessarily the full thing, but kind of like the next iteration from this. Because I don't want to get into the whole like implementing our own file and directory stuff in the way that the S3 one does yet, because I want to kind of understand the requirements. And even though it's kind of funky working with the mem file implementation, it's a little bit easier, like just less stuff to write. And so then after we've done that, we can get off the mem file and make our own file implementation and all that. So read files, and maybe we have to do that before we get to writing files because of the complexity that might be involved there, but we should at least try and get reading files to work. How does deleting work? I'm guessing that's actually just creating a new tree without the file, right? Committing a tree that doesn't have a file. Because there's no, like, you don't delete. I mean, you typically don't delete stuff in Git. I wonder, though, if there's any high-level stuff. Delete repository. Contents. Delete a file. This might be a convenient shorthand for the remove operations. I don't think that there's any downside to using this. In fact, that might be like another easy one. So delete files using contents API. I don't think there's a downside because this is going to do some stuff for us, and so we might as well just take advantage of that. Is there rename? Delete, update a file. So I wanted to like the name of the commit. Okay. I don't see how you would rename a file using this API. You can imagine delete it and then create a new file, but that would do 2 commits if you're using this API. So I imagine what we'd to rename, we'd have to do the create a new tree and change the file name there. So it's kind of interesting. It's a little bit more like into the Git internals. I mean, I mostly know it, but I haven't ever really done stuff with the Git internals. So it's like some of it I was like, oh, trees are mutable too. I didn't realize. But I think other than that, it's pretty straightforward. So let's see. So if we can write files, delete files, what else is in our thing? Create, make directories, which I guess that's kind of like an internal thing because we wouldn't have anything to actually push to Git. So internal representation of directories made with Victor. We'll see. And also we're kind of doing everything in this sort of stateless, like, so a lot of this stuff will kind of evolve as we're getting through kind of a prototype. Open file, remove all. By the way, if you guys do, if any of you just want to go all the way and implement all of this, that'd be cool too. Because this is only a means to an end. But ideally, if you wanted to do it in this repository, that would be great. So that anybody that sees this would then find the final thing on GitHub. Change. Mode, we talked about that, and this will just be a no op, I'm pretty sure. I should say GitHub API. I don't think this is used for anything other than just like, oh, it's nice that afero file systems have names. Yeah, I think that's about it. Read files, delete files, virtual internal directories, writing files is a lot of stuff. I mean, we could also use the contents API for that, because every operation that we do would be another commit, just because there's no way to kind of represent any kind of batching when you're using the afero API. So maybe this can use a contents API. But there might be some cases where like renaming files and stuff, I guess renaming, that's part of the API, right? Open, remove, rename, yeah. Which would have to be a new tree. So, and then we probably do want to get off of this just so that we can lazily load stuff. So that's pretty good for today. I mean, we got kind of like the basics, got comfortable with the GitHub API, kind of understood architecturally and how we would interact with the API to implement everything. And we have something that's actually working. We can list the directory using, this is a helper function. So using a high-level helper function that operates in the same way that any other kind of file system thing to read the directory would. We can read any directory in a repository. Yeah, this is a good first step. I did think that we would get further in this. I actually had the crazy notion that we would do all of this, everything, in an hour. It's been 2 hours, but I think the second half will go much faster now that we know what we're doing and what we want to do and how we're going to do it. So I don't see any questions, so I think that's it. I'm going to wrap things up, and I'll let you guys know when I'm doing this tomorrow or later in the week. But thanks, everybody. Bye. I'm still